Hello everyone, welcome to our presentation. Today we'll be discussing containerization versus virtual machines, focusing on the security and efficiency trade-offs between these two major visualization technologies.
So this topic is very important for modern computing, especially with cloud environments, DevOps, pipelines, and distributed systems. Let's begin.
Slide 2. Visualization has become the foundation of cloud computing. Traditionally, virtual machines dominated data centers, but in recent years, containers have become extremely popular due to their lightweight nature.
In this presentation, we will compare their architecture, security, performance, and use cases, and finally discuss the future trends such as micro VMs.
Slide 3. Machines. A virtual machine runs a full Quest operating system, such as Windows or Linux, on top of a hypervisor like a KVM, VMware, or Hyper-V. Because the entire OS is virtualized, VMS provides strong hardware level isolation.
However, this comes with downsides. VMs use more CPU, memory, and storage, and they take a long time to boot. They generally have more overhead, and they remain useful for applications requiring strict isolation and succeed guarantees.
Slide 4.
And what are containers? Containers are much lighter. They do not have a full guest OS. Instead, they share the host kernel while providing isolated user spaces.
Because of this design, containers start in milliseconds, use far fewer resources, are ideal for microservices and cloud native applications. Technologies like Docker, LXC, and containers run millions of workloads daily. Let's go slide 5. Here we see the architectural difference clearly. VMS have hardware, hypervisor, Quest OS applications. Containers have hardware, no, host OS, container runtime, and application.
So, because containers skip the guest OS, they scale much better. A server might run hundreds of containers, but only dozens of VMs. However, the shared camel model impacts security, which we will discuss next in the slide 6. Security is the one of the biggest differences. VMs have very strong isolation because each VM has its own camel and OS.
Containers, on the other hand, share the same kernel. So if the kernel is compromised, all containers are at risk. Modern tools help improve container security. AppArmor, CLinux, seccomp, um, rootless containers, and others. But still, VMS remain the safer option for high security workloads. Let's see slide 7. Performance compression. In terms of performance, containers are usually 20 or 40% more efficient than VMS. They use less memory, have faster EO, and boot instantly. This make them perfect for scaling web application or microservices.
So VMs still have advantages, especially for heavy workloads. They require dedicated resources. But for the most cloud workloads, containers offer better overall performance. So let's go to the slide 8. In slide 8, today containers dominate the cloud computing through platforms like Kubernetes. Kubernetes provides auto-scaling, load balancing, rolling updates, and service discovery. So it's your turn.
Uh, Interestingly, Kubernetes itself usually runs on top of VMS, meaning both technologies work together. Hybrid deployments are becoming the norm in large cloud environments. Uh, Slide 9. Yes.
Use cases.
Containers are ideal for microservices, CE/CD pipelines, web apps, stateless applications, and
And
others.
and VMs are ideal for legacy applications, security critical workloads, databases requiring strong isolation, full OS environments. Together, they cover almost every modern computing scenario.
Slide 10.
And the future directions. This future is heading toward hybrid technologies, combining their strengths of both models. Example include AVMs, Firecracker, micro VMs, Kata containers, gvisor, sandboxing containers, and confidential computing.
These tools offer VM level security with container level performance, giving the best of both worlds. Slide 11,
Conclusion.
conclusion. Yes. To summarize, containers are faster, lighter, and more efficient. VMS offers stronger isolation and stability.
So when we look for the winner, there is no winner. Both are essential. The right choice depends on the workload, security requirements, and infrastructure.
Thank
Thank
you,
you for
boss.
thank you both, and thank you for listening. If you have any questions, we will be happy to answer it.
See you.